In the previous section, we described the basics of using Sub VIs in LabVIEW. By the end of this module, you will be able to describe the basics of Sub VIs, Re-Entrancy, and Non-Reentrancy in LabVIEW Fpga. Now let's talk about using Sub VIs on the Fpga. So you can run only one top-level Fpga VI. Okay? However, you can have several Sub VIs. So remember before when we were talking about it's bad to put large controls and indicators on a front panel? Well, that only applied for the front panel of a top-level Fpga VI. If you're using a Sub VI, on the Fpga Sub VI, you can place large controls and indicators on that. And the reason for that, it's because Sub VI controls and indicators are not exposed to the host. Only the controls and indicators that are on your top-level Fpga VI are exposed to the host. So now let's talk about Re-Entrancy and Non-Reentrancy in Fpga. So if you're familiar with LabVIEW on Windows Target, when you create a Sub VI for Windows, by default, the VI properties is going to show that it is a non-reentrant Sub VI. Now, when you create a new VI in Fpga, by default, it's going to be different. By default, creating a VI on Fpga is going to be re-entrant. So just wanted to point that out to you. One of the reasons why we would do that on Fpga is on Fpga, it's easy to have a lot of things run in parallel. Okay, so that's one of the reasons why the default is set to re-entrant. So let's take a look at a re-entrant Fpga Sub VI. So if you're using a re-entrant Fpga Sub VI, each instance of that re-entrant Fpga Sub VI on the block diagram becomes a separate hardware resource on the Fpga chip. So if we take a look at the block diagram on the left, notice we have a re-entrant Sub VI and we have 3 instances of it. If we look at how it's implemented on the Fpga, notice that Sub VI is actually implemented 3 different times because we have that Sub VI 3 times and they're all re-entrant. Okay? Now let's talk about a non-reentrant Fpga Sub VI. So if it's a non-reentrant Fpga Sub VI, then there's only a single instance that's shared by multiple callers. That means every time someone wants to call that same Sub VI, it's going to have to wait for somebody else to finish using it. So each call to the Sub VI waits until the previous call ends. So in this case, it's not going to allow parallel execution of that Sub VI. So let's take a look at this block diagram. Notice that we have 3 instances of this Sub VI, but this is a non-reentrant Sub VI. So if we take a look at the way that it is implemented on the Fpga chip, it's only implemented once. Because there's only one implementation of that, those 3 loops are going to have to share that one implementation. So if the top loop is using that non-reentrant Sub VI, the bottom 2 loops have to wait until the first loop is done with it before they can access it. So now let's take a look at the trade-offs between re-entrancy and non-reentrancy for Fpga VIs. Okay? So first let's talk about Fpga resources. So with a re-entrant Sub VI, there's a separate one that's implemented in the Fpga for each instantiation of it on your block diagram. So typically that's going to use up more space on the Fpga. Now let's look at the non-reentrant Sub VI. There's a single implementation on the Fpga chip for all instantiations. So typically it's going to use up less resources. Now let's take a look at parallel execution. If you have a re-entrant Sub VI, all those Sub VIs, because they're implemented multiple times on the Fpga chip, they're going to be running truly parallel. For a non-reentrant Sub VI, because there's only one implementation of it on the Fpga chip, it won't be able to run in parallel. So if we were to generalize, a re-entrant Sub VI will be optimized more for speed because of that parallel execution, and a non-reentrant Sub VI is typically more optimized for size. Now let's take a look at use in a single cycle time loop. A re-entrant Sub VI will be able to work in a single cycle time loop because there is a separate implementation of that on the Fpga chip for that re-entrant Sub VI. However, if you have a non-reentrant Sub VI, it might not work in a single cycle time loop. The only way a non-reentrant Sub VI will work inside a single cycle time loop if it is only called from one place. That way we know that it will never have to wait for another loop to finish using that non-reentrant Sub VI. Because in a single cycle time loop, it has to execute within one clock cycle. So we can't have a Sub VI in there that needs to wait on another loop to finish using that Sub VI.